So exploratory seminar number 25, time series forecasting with profit. This is a topic that I have presented almost like a year ago, but since then we have added many features and then functionality around this area. So like I thought like that, this is a good timing to revisit. To do, like I like to do, like introducing what the time series forecasting with profit, how what it is and how it works, and also some of the cool things that how you can use it, or how you can sort of like fine tune the forecasting model. Also, like I want to cover like how you want to evaluate the model quality in terms of like a forecasting quality. Okay, so let's start with basic of time series forecasting. So like typically with or without profit, it's just a traditional world, like in a sense, time series forecasting is considered as a supervised training, and based on the past data, and then build a model, and then you want to forecast the future. Right, so that's really what it is. And a traditional statistical approach, in the typical approach, is to pick previous periods. Let's say like day 1, day 2, day 3, and then you want to predict that day 4, and then like you kind of like shift those period, and then like you want to forecast the next day, and then like you basically create the model to do these types of things inside that model, right? So, and then the problem with that traditional approach is that the number one, that your data needs to have the exact time interval. You can't have, let's say, like February 1, February 5, February 6, February 7, and February 15, or something like that. Every single, like let's say, like if you want to do the daily, like you have to have like 1, 2, 3, 4, 5, 6, 7, 8. So it has to have the data has to be the same interval. And then NA is not allowed, so like you have to have certain values in every single period. And also, it's hard to deal with the multiple sort of like seasonalities, such as yearly seasonality and weekly seasonality, or daily seasonality kind of stuff. Like, it's hard to put those things together in the same model. And parameter tuning is very hard, and then requires usually the professionally trained knowledge. Right. So these are the typical challenges. Might not be applied for every single forecasting model. These are the kind of things that like sort of like the barrier for many people why they have not been able to do the time series forecasting. So now here comes the profit. Profit is really, one single sentence. It's really a curve fitting algorithm. It's almost like, think of it as like a kind of machine learning, or even like a random forest, or even like deep learning. It's just not in a more like a traditional statistical way. It's more like, hey, here's a sales trend, and how can I draw that line that fits very close to this sales trend that I have. It's almost kind of like that. And this algorithm was built by data scientists at Facebook, and I think they have already left Facebook. However, I think this came like, I think it's 3 years ago or so, and it was open source, so you can use it, by downloading from GitHub or whatever. But it's also available in R and Python. So yeah, and then also I think this is a really cool part about this, is that it was designed for ease of use, and also if you have the domain knowledge in the business, then you can actually fine tune it better. And then without needing for like professional time series forecasting or statistical side of the knowledge or experience. So it's very easy to use I think it's this profit algorithm democratized data science, time series forecasting. And it is an additive model. I'm going to talk about this a little bit later again. But additive models, think of it as like the multiple components. And then like, you combine those or some of those components and then get the forecasted values. So what are those components? These are the four kind of main things. Number one is the overall trend. So let's say like it's the sales, if you want to focus the sales, and if the sales is going upward or downward or which direction it's moving, type of overall trend. And then seasonality is a yearly and weekly. I'm going to talk about this more detail after this. And then the holiday effect, like if your business has, maybe like a Christmas season or holiday season is important in terms of like sales forecasting, then you can bring that in as well. And also external predictors, let's say like your marketing spend increase the sales, then you might want to bring that kind of stuff in the model. So these are the components, and then this algorithm find there's some patterns and the trend in those these components, and then build this sort of like kind of trying to build a smooth line that fits with actual data. In this case, let's say like sales or something like that. So what that means, so let's start with the overall trend, right? So this blue dot like that. Let's say, I think this is like a count data or something, like how many page views on each given day. And then typically, like when you have such time series data, like you want to use a line chart, right? So this line chart is basically connected to all the dots, okay? And then the trend is like this orange line. So it seems like kind of going down a little bit and going up or something at the end. And this is a very sort of like a loose trend. It's not like matching with the actual data day by day or something like that. This is more like an overall trend, right? And then next component is a seasonality. So let's say like let's bring a yearly seasonality. And seasonality, yearly seasonality means it's like every year, like there gotta be some pattern that repeats again and again. So let's say like every July, like, our sales goes up and then December goes down kind of stuff. So it's sort of think of it as a kind of monthly change or trend or something. So that whatever the trend, or sorry, whatever the patterns that repeats yearly. And then like, this is the additive model, right? So that means we combine the yearly seasonality and the trend together. So that's this orange line. So this one is like the combined together, just basically the adding two numbers for each given date. And then we can bring the weekly seasonality. And the weekly seasonality is similar to yearly seasonality, except it's the repeats every week. So let's say like every Monday, the sales goes down, and every Friday, sales goes up or something like that. So this green line is a super like tiny things, but because it's repeating every week in the same pattern. And then this is an additive model. So like you want to combine this weekly into the trend and yearly, the orange line. And then it becomes this sort of like a super spiky orange line. And then now, like you notice, this orange line started very looking kind of like a closer to the actual data, so which is blue. Right, so now at this point, we combine trend and yearly and weekly. And there's certain points still like not really matching. So notice that like those two super like spiky sort of like a hill or the peaks, right? Around July 2016 and then also July 2017 area. And it turned out this is a wiki page of like Apple Worldwide Developers Conference page. So when they have that event, and then right before or like during that period, everybody goes to that wiki page or maybe Google, and then ended up going to the wiki page. So therefore, like there's huge spike around that around those days. So if we know that, then like we can say to the prophet, hey, these are the days that is a very special day, like we call it like a holiday. So we can put that information in the model, and then the model will figure, hey, you know what, there's some kind of patterns, and then this much of the effect comes from the holiday period. And then we can get the holiday effect combined with the trend and the yearly and the weekly. And then at this point, the orange line even more fitting to the actual blue line. And of course, there are certain points that there's some difference, and that can be another type of the holiday. Let's say maybe, you know, some kind of, like a holiday thing or summer vacation thing or back to school thing or whatever. And if you know those things, and you can bring those things as a holiday. Like, so holiday doesn't have to be just one type of the holiday. Like, you can bring different type of the holidays as well. Then you get this orange line. This is basically the model, right? So like model is forecasting, and then even the past. And then the very right-hand side, there's no blue line. That's the period that we don't know yet. And therefore, this model is forecasting. This is how it's going to be like over the, let's say, like next 12 months or something like that. So the benefit of profit approach, the approach by the profit, is that basically addressing all those challenges that we saw with a traditional forecasting model. So it can handle uneven time intervals, and also can handle dates with NA, and it can handle multiple seasonality like we saw, like yearly and weekly, and also works well by default. That's very important. So like if even without any background in time series forecasting, you have the data, time series data, and then you can just give that to profit, and then you get you get something that seems to be very reasonable most of the time. Of course, your data has to have certain type of patterns and trend. If your data is kind of like wacky, like no trend, no pattern kind of data, then like, you know, the algorithm can't do anything much. But it turned out many of the time series data tend to have some sort of like a trend. So in that case, you get very reasonable result. But then here's a cool thing. You can improve it, like the default setting. So default setting is great, but if you know if you have the business domain knowledge, such as like a holiday, hey, these are the dates that, you know, very special time for our business, you can bring that knowledge into the model. Or let's say like you, let's say building a forecasting model, but you know that, you know, that the value never goes more than higher than the, let's say like 100, less than the 0 or something like that. You can bring those information in, knowledge in. And I'm going to talk about that a little bit later on as well, in terms of this like a fine-tuning part of it. Okay, so let's see like how it works. And if you have Exploratory, you can actually quickly do it. I'm going to show you a quick demo from here. So here's the sales data, and then each row is each order. Think of it, and then we can basically use the chart to get the trend of the sales, something like this. And then here, okay, so here's the data. Okay, and then I want to see this. Basically, here's a date, and also there's a sales, right? So I want to create a simple, very, very simple chart, like order date, and then let's say like a monthly sales trend or something like this, right? So like now the question is, so this data happened to be up to 2015 end of December, 2015 December. And so this is kind of past data. Usually this data is up to today or something, right? But let's say like how that sales is going to perform over the next 12 months. Like where should we draw the line, right? Basically like going up, and looks like going up, but how it's going to go up, right? So that's the where the time series forecasting comes in. And then so go to the analytics tab, and then select this time series forecasting profit. Then the date time column, like you assign the order date. And then you can choose like which, how you want to aggregate the data. And in this case, let's start with months. And then the value column is, so this is, you notice that like I'm basically doing the same thing of creating a chart, right? So nothing different. And then like at this point, I click the run button. And then this, take a look at this blue line. This blue line is basically the chart that I've created just a minute ago. And then here, based on this data, it builds a forecasting model. And then it forecasts. So that orange line is the forecasted values. And obviously the last part, so like here is a 2016, we don't have actual data, but model is forecasting for that period. Okay, and then this range is something called uncertain interval. It's very similar to confidence interval. So there's depends on like how much data there, and then like the range gets wider or shorter or something like that. So now here, like what this period, this is like a forecasting period. Well, this period can be controlled and how you do it. So here is a property. So click on this property and then forecasting time period. So default is 10. The unit is depending on how you aggregated that data. So here is I'm using the months. So that means this 10 meaning the 10 months. So I'm gonna just change that to 12 months and then see like how this model is gonna forecast. And then you see like it used to be up to here, up to October, which was default is 10 months. But now like I added 2 more months by setting the 12. So this is, like let's say like 12 months later, like we're gonna get sales to be somewhere around here. Right? That's really the basic of the time series forecasting. And then now from here, you can, so how this orange line being drawn or how the model is being built. So you remember like I was talking about additive model. So it adds, it basically creates a components, like which is a trend and yearly and other stuff. So here you go to the trend tab, and then, so this green line is the overall trend. And you see this like a light green bars, these are called change point. And then, so change point, this green bar is actually using the right side of the scale. And then, so left side of the scale is the sales. This is a total change. It's again a percentage. So how much is the percentage change in terms of trend? Right now, this trend is a linear, so like it's supposed to be a straight line. However, when you have this kind of change point, that what do you call it, slope of the line gets changed. And then, so it's a little bit like around here. So what that is seems like the sales trend changed in January 2015. I mean, like a late 2014 to beginning of 2015. Some kind of things happen in business or something, and then trend has started changing. So it captured that types of things as well. And then also yearly trend, when you go to the yearly tab, and then you see here, this is yearly seasonality. Therefore, like what you see here repeats every year, right? So let's say, looks like from January to May, the sales is relatively kind of slow. And then like after that, like June, sales goes up, and then July goes down. And the rest of the year is relatively high. And then like I think the peak is November, December time. So this is a pattern that repeats every year for this particular business, right? This particular data. And how are they correlate, they combine? So here, when you go to the effects tab, and this gray is the forecasted value, the orange color that we saw under the forecasted tab. And then this green is the overall trend. And then this blue is that yearly seasonality, the pattern that repeats every year. When you combine this green and then this blue line, then you get this gray. So that's what I said, like an additive model. Yeah. So now with this, that's the very basic of the forecasting model. Oh, one thing though, so now we got this like a yearly seasonality, right? So, but we don't have like a weekly seasonality. Let's say like I want to know if this business like a Friday tend to be higher, or maybe like a Sunday tend to be lower or higher, that kind of stuff. Then we don't have weekly. That's because this data was aggregated by months. So that means we don't really have the granular data that model can or algorithm can detect the weekly trend. So how are we going to do it? Well, you can get to the lower granularity, so like a day. If you aggregate this data by the day, then that means you're giving like Monday, Tuesday, Wednesday data. Therefore, it can detect. So let's try to do it. So if I set the day and then click run button, then now this is, if I go to the forecasted tab, and then that line becomes super kind of crazy because now like we are forecasting by daily. And then like when you go to the weekly, so this is weekly seasonality. So looks like Sunday, Monday are slow for this business, but then from Tuesday to Saturday, Saturday, relatively higher than the other days. And when you go to the effects, like you see how those like additive components. So overall trend, and then blue is the yearly, and then now here red is the weekly seasonality. When you kind of go zoom into it, and then so this is the trend repeated like every week. Yeah. So one thing though, you notice here somehow sometimes like it goes really down here. So like like I said, like this is weekly seasonality repeats every week. But then how come there is some kind of weird stuff going on here? Well, when you see something like this, typically it's affected by NA, and then Profit is able to deal with NA. But however, when you have NA and then the seasonality sometimes get drawn like this, and it might be okay, but if you want to do more better way, and then you can actually adjust the NA. So in this case, what do you mean by the NA, right? So like I'm basically aggregating by day. And then NA means this given day, there's no sales, maybe like there's no data, or there's nothing's happening or something, right? So in that case, in this particular case, it's a sales. We're talking about sales. So like we can consider that as a zero. If we don't have the sales data, that means zero sales. And in the case, you can click on this property and then scroll down. There's a data processing section. This is where like you can impute the NA. So for example, like I want to do like fill with zero, or like the other options as well. But let's say like if I select the field with zero and then click on apply, and then rebuild the model, and then like I think we should be seeing this sort of consistent repeatability of the weekly seasonality. Okay, so that part is not as the exciting part, but I'm going to just bring it back to the months. The point here is like when you have the daily, then you get the weekly. And this actually goes to the same thing. There is a daily seasonality, which is, let's say, like every around the noon to 1, it was a lunchtime, like our business, sales goes up. But then like after, let's say like 5 o'clock, sales goes down, then 9 o'clock goes up, so that's called daily seasonality. To get that pattern or to get the daily tab, then of course you gotta have the column that has the time. So right now, this column is a data type. When you have the time information data, then like you have like a POSIX CT represent calendar time. Then like you have, you're gonna have the menu of, let's say like hour or minute or second or something like that. And then when you do so, then you get the daily tab as well. Okay, so I'm gonna just click on the months and then here. So now when you get this model, sometimes like you wanna see like how good this model is, right? So this happened to be, I mean, it looks like it's very reasonable. Why? Because the orange line and the blue lines are kind of matching. But let's say like how those good or bad, or you want to evaluate the forecasting model. So that's the topic that I want to actually talk about from now. How you evaluate. So typical way to evaluate is something called backtesting. But what this really is split the data into 2 sections. One is training period, and one is a test period. right? So you can set like, the adjust the test period. Let's say like last, you have like 4 years of the data, and then you want to use the last 1 year as a test period or something like that. Then what's going to do is use the training period data to build a model, and then forecast for the test period. And then because test period, we already have the actual data, therefore we can compare the forecasted values against actual values. And if you evaluate the model based on like how difference, how much of the difference between the actual and the forecasted. It's very similar to, if you're familiar, the machine learning or statistical learning models, and that's basically what it is. So you can do so, and then let me just go back to Exploratory here to do the testing here. So I can click on the property and then scroll to the bottom, to the evaluation section. And then default is false, so it's not like a testing here at all, but you can actually change that to true. Now it's in test mode. And then you can set like, what is the test period? So here, again, this is very similar to like forecasting period. So the unit is based on the aggregation level. So right now I'm using months. So if I say 10, that means the last 10 months, right? So like if I'm going to just do the 12, because this is like a 4 years of the data. So I want to use the last 1 year of this data to be the test period, and the first 3 years as a training period. And I'm going to just click on this apply button. And then you see here, dark blue is the actual data in the training period. This light blue is the actual data in the test period. And then the Prophet built the time series forecasting model for by using only this dark blue data, and then forecast. And so therefore now like we see this light blue and then orange, it's kind of matching, but not quite matching compared to the first 3 years. And then we want to, we can evaluate this model based on the difference between blue and orange, how much different. And there are a couple of metrics. When you go to the summary tab, RMSE, MAE, MAPE, MASE, these are 4 metrics. Now I'm gonna introduce those metrics from now here. Okay. So, and if you're interested, I'm gonna share this slide later. If you're interested, you can read, but I'm a very picture person, so let's go with the picture. So let's start with the RMSE. This is actually the same concept that like we see in a linear regression or even like a machine learning model for the regression model. So what it is a root mean square error. And then square the errors when we set errors, which is the difference between the blue line and the orange line. And then basically square the errors and take the mean and the root the mean. Why we square? Because sometimes it goes, the orange line might be higher than the blue, might be lower than the blue. So when you start like a kind of try to get the average of the difference, you ended up getting closer to the 0. So therefore, in that case, like you see very typical thing to do in the statistics world is like you square and then root that squared value later, and then that's what it is. So, but the point here is we want to get the sort of like an average of the difference. And then one way to do it is this root mean square error. And then here's the detail calculation. If you want to understand how exactly it's calculating, you can take a look at this slide as well. So next one is MAE. It's very similar idea to RMSE, except it has it deals with that sort of like the problem that I just talked about. Orange line might go higher than blue and it might be lower than the blue. And in that case, when you start adding those differences, you ended up getting closer to the 0. But here, in order to prevent that, like instead of squaring, it absolute that values. So absolute that differences or errors, and then take the mean, right? So RMSE, MAE, basically very similar thing. And there's another two. So those two, RMSE, MAE, are very common metric, but there's some problem with them. That is, if you are trying to compare among the different models, and then let's say like I want to create a model for let's say a particular region, like a North America market, and then like another one is for like Asia market, and then those two different markets have a different variance or standard deviation or standard different type of scale. So let's say in America, like we have like all the sales, let's say $1 million, and then Asia, let's say like all the sales, maybe like $100,000 range or something like that. Then the RMSE, MAE tend to be different between the North America market and Asia market because the raw values are very different, right? So then like we can't really compare those two models, one for North America, one for Asia, because the scale is very different. So like when you get like RMSE 500 and then the other one, like you said, RMSE like 1 million, you can't really compare because it's not, we're almost comparing orange and apple. To address those challenges, there are two other metrics. And one is called MAPE, MAPE, or mean absolute percentage error. So we want to make that as a sort of like a percentage, absolute percentage differences between the actual and the forecasted, and then take the mean. So what the percentage means. So let's say that each actual values makes that as a sort of like a 100%. And then, so it's almost like this. So, and then the error or the differences between actual and then forecasted values are like how much of the percentage of the whole, like actual value. And then you calculate those for every single data point. And then eventually you get the mean. And that's the mean absolute percentage error. So now here, we are talking about a percentage. Therefore, the example of North America and Asia, the scale is very different, but it doesn't really matter. So here you get something like this. Then another one is MASE, which is the mean absolute scaled error. It's similar to that. I think what it tried to do is very basically to try to address the same problem, but it's a different approach. And this is kind of interesting. How we do it is MAE, you remember, like mean absolute error in the test period, and then MAE of a naive prediction model in the training period. So what that means. So naive forecasting model is to forecast whatever the previous value. So let's say if it's yesterday is $500, then this naive forecasting model predicts $500 today. And of course it's different, like today can be $600, but the naive forecasting model see that today is the same as previous day, which is yesterday. So this orange is the naive forecasting model, and the blue is the actual data. And then you basically get the differences, right? So between the actual and then this prediction model or like naive forecasting model. And then evaluate that as MAE, calculate that as MAE. And then, so that's the naive forecasting model. And then you get the MAE in the test period. This is not naive, this is like actual one. And then like you basically compare these two and see like how, how much of the difference in the MAE in the test period. And again, this is also the ratio. So therefore, it doesn't you don't have to worry about the original scale, and instead you can actually compare among the different models with a different scale in actual data. Okay, so now that we know those metrics, let's get to the seasonality mode. So I want to actually cover this just quickly here. So like we have like RMC, here's a 61, or MA52. So this is, think of it as kind of like average differences between the forecasted values and actual values. So like let's say like this is $61 or $52 differences between these two in average. And then here is MAPE and MASE. These are, MASE is a ratio, so it's like a 79%. Is that here? So this MASE is a 79% or something. Okay, so now here, like we get the cool thing. So we get this focus, so test period, right? Like you, as you see, like there's kind of like a big difference between blue and orange, compared to there's no almost like no difference between blue and orange. So what's happening here, right? So so that's where the seasonality mode comes in. So there are two concepts: there's the additive seasonality mode and a multiplicative seasonality mode. So this model is assuming the seasonality variability stays the constant. So that means we have like 4 years of the data. And then the yearly seasonality or weekly seasonality will repeat every week or every year. And that is constant. And that's the basically like additive seasonality. But then the problem is the data we have, we are talking about sales. And typically the sales is not really additive. It's more like multiplicative. What that means. So right-hand side, left-hand side is the additive growth model. So, you know, typically, like, let's say like a very stable company, and then keep adding the employees every year. Let's say like, you know, 50 people every year or something like that. And the right-hand side is, this is Amazon's sales trend or something, but, you know, it doesn't have to be Amazon. Like it's just a very rapid growth company or something. Then those, when you talk about their growth, we don't usually talk about what $2,000 up or $2 billion up. I think we might say that too, but typically like 20% up compared to the last season or last year, right? So what that means is that in a certain type of the business or certain type of the data, it grows by percentage. And a certain type of the data, certain type of the business grows in terms of like sort of adding the numbers. So these two different growth model. And then the multiplicative is sort of like, think of it as kind of like what do you call it? Kind of like a snowball kind of business. Like once you have every year just 10%, and then like next year 10%, meaning after grow 10%, right? And then like you multiply 10%, so like it gets higher and higher and stuff. It's more like exponential growth curve. So the two types of things. And then if you have those two things, and then that actually, you can bring that information in. So it really depends. This is where sort of like domain knowledge, not that's forecasting domain knowledge. It's more like business domain knowledge actually matters. So if you're a business, you think it's more like a multiplicative business model, then you can click on this property. And then under the seasonality section, the seasonality mode, default is additive. You can change that to multiplicative. And then click on the apply button. And then here, so now notice that like orange and this light blue was getting closer compared to that last time. But I also noticed that like the blue and orange are kind of like not as fitting like the one before, right? So basically the difference are kind of like consistent among those years, like 4 years. Now, like the last additive model, you see the difference only towards the end, but now like you see kind of like evenly. And that's, I want to actually talk about a little quick on this additive and multiplicative. That can be complicated for those who are not familiar with this concept. So here's the additive model and then multiplicative model. I built this forecasting model by weekly with a weekly data. And sorry for the x-axis, which is kind of Japanese, but it's actually the month's name. So now, seasonality effect is constant with additive model. With what I mean is it's this blue, think of it as the kind of length for this blue, right? And then, so let's say, for example, in, like June, yearly seasonality goes up this much, and that means that repeats every year, right? And then that amount of the change is always the same. But multiplicative model is actually that it repeats at the same timing, right? Like every June, but the amount of the growth, amount of the change gets bigger and bigger. In this case, bigger, and sometimes can go the opposite side as well. And then when you take only the blue line, and basically we're comparing something like this, right? So like the additive model, when I said constant, that's what it is. And then the multiplicative is that change itself is growing. So yearly trend and also weekly trend can grow this way. And then, if your data, let's say in this case, the sales is growing, it's multiplicative way, then I think that's the model that you want to use. Okay. And then when you compare this, I think key thing is like if you're not sure like which model you should go, like you want to try that in the test mode, and then you want to use these metrics that we talked about, and then compare those between these two. And then typically, if it's multiplicative model is better, then like all the metrics are suggesting is a better score. So RMSE, MAE, and all these numbers, it's smaller the better, because these are about the differences between the actual and the forecasted value. So the smaller is better. Okay, so now another cool thing you can do in here is there's a repeat buy. Repeat buy is a name kind of sometimes confusing, especially for the people who just starting out exploratory. But repeat buy is basically it's partition the data into number of the categories. So in this case, let's say like I'm going to select the market, and the market is North America, Europe, Asia, Africa, and so on. And then build a model for each partition data. So one forecasting model for North America, one forecasting model for Asia, and so on. And then like, we can actually take a look at those and compare them. So click run button. Here we go. And then like, so now we get like Africa, Asia Pacific, Europe, and so on. And you can actually change that layout by changing this like number of columns to, let's say like I'm going to change that to 3 or something. And that's this is you see like we can compare this, and then like obviously like Africa is a number. This like a y-axis is a sales, so sales is low. So it's not so easy to compare with others, but you can see. And also another cool thing here is that how much of the difference between the model and then the actual data. In other words, which market is easier to forecast? And if the orange line and the blue lines. Okay, just a second. I'm gonna mute all. There we go. Okay, sorry about that. Okay, so now basically we want to see is which market is easier to forecast. And also we can see the trend, the different types of trends happening in the different markets, right? So for example, maybe Asia Pacific seems like this like June is super high. And then compared to like Europe is also maybe June is high, but the US is not so much. And then how can I see it? Basically, when you go to that yearly, and that's where yearly seasonality we can see. So for example, USCA, this is like North America, US and Canada. Here, September and also November and December, the sales goes up, right? But Asia Pacific and Europe, like they have like a June is kind of like a higher spike, and then goes down, and then but this seems like a summer, they make a lot of money in the summertime. And then Latin America is like a January, February kind of slow, and then after that start going up. So this is like a yearly seasonality. And that actually is, you can see in the forecasted here as well. And also another thing is when you go to the trend, this is like an overall trend. So like it looks like Asia Pacific is growing super so much compared to others. USCA seems like kind of like getting slower now. So you can find this type of information easily as well. Okay, so that's and then another thing. One question like I didn't answer yet is like which market is it's easier to forecast, right? Like or this better for this model is feeling better. So here now like each market. So when you do the repeat buy, now like basically behind the scenes there are like 5 forecasting models were built. And then each model has its own metrics, right? So here, let's say let's focus on the RMSE, and it looks like this like a smaller is better. So you know when you look at this number, like Africa is the smallest, like 6,449, and then the biggest 20,000. But this is where like we have to be careful because that when you look at the forecast here, that numbers, like the sales values in Africa is much smaller than other markets, especially like Asia and Europe. So when you look at this RMSE, in this case, because Africa's sales values are smaller, therefore like RMSE already small, right? So that's not really the orange and orange comparison. So that's where like you want to use MAPE or MASE, these metrics. That's more like the percentage or ratio and stuff. So here we have like, let's say like MAPE, like 27%, or MASE is 85%. Compared to Asia Pacific, which is like 13% or 56%. So therefore, it's actually Asia Pacific is performing better in terms of like model quality here compared to Africa. So we can say, for example, okay, like Asia and Europe is, you know, it's easier to forecast, or when you create a profit times this forecasting model, it fits better for these markets data. Okay, so now that here's the last topic. So when I go to the chart, right, go back to the chart, and then I have like a sales trend, right? And then let's say that there are other variables like quantity, discount, marketing, sales comp, and so on. If I bring the sales comp, and then this is like orange line, and then if sales comp and the sales are correlated, and then like can we use that information into that profit? So what I mean, so let's say like now it seems like scales are very different, like sales comp and sales. So I'm gonna assign the sales comp to the Y2 axis, right? Assign to Y2 axis like that. Okay, so now orange line is using the right hand side scale, and blue line, which is sales, is using the left hand side scale. And it seems like they are super correlated as long as I see. And how about the marketing, for example, here? And marketing also seems to be correlated with the sales values in terms of this time series wise. Or how about a discount? If discount, we don't want to sum because this discount rate. So like I want to change that to average. And discount rate is not so much in terms of like correlating to the sales, right? So let's say like sales comp and the sales are correlated. What that means, maybe if we, sales comp is a compensation, right? So that means if we pay more compensation to the sales folks, then we can get, here we go, I'm gonna change that to sum. Then we can increase the sales. Or if we reduce the sales comp, then maybe sales goes down as well, right? So if that type of the knowledge, if we already have, if we know those two are correlated, then can't we bring that information into the model? Because the cool thing about this type of thing is that, like, let's say like over the next 3 months, like I'm planning to do like a sales comp sort of like a model. And then like I wanna, you know, I'm kind of trying to figure out how much should I add, or even like make sense to add or not. And this is also another thing, the marketing, like what's the marketing budget to be like next 3-6 months, and then should we pay more, should we pay less, kind of stuff. So if we know, that's great. And if we don't even know, then we want to find, are there any like a correlation between these sales in terms of time series forecasting? And then that you can actually use this external predictor. So I'm going to just take off this repeat by. And then, then I'm going to assign this external predictor to, let's use sales comp. Okay. And then click on run button. Okay, so this is the model that it's using. That's not just like a trend and yearly, but also now this like a sales comp as an extra predictor. And what that means is that when you go to the effects, okay, so you remember this profit is additive model. So therefore it adds the trend, which is green, and also the yearly seasonality, which is blue. And then this time, it's also adding the sales comp as a predictor. And then this, combine all of these three, and it becomes this gray. And then by the way, the sales comp and yearly seasonality is using the right-hand side. It's like a multiplicative effect side of scale. Okay. And then when you go to importance tab, and then you can see like sales comp has more effect than the yearly. And you can compare between the seasonality and external variables, external predictor variables. And then not only the sales comp, you can add other variables too. Let's say like not just the sales comp, like I want to see like a marketing and also the discount. And let's pretend, and I'm going to set that like average for the discount. Right, and let's pretend we don't know which variables are correlated to sales, right? And then it's, but we want to understand if any of the variables help to forecast the sales, because if we know it, then we can use that knowledge to take actions, right? So I'm gonna just click run button here. And then here, like I can see, so this is actually the bug in the latest release of the Exploratory. So this is supposed to be these bugs should be sorted, but somehow it's not. But anyway, so here we can see the sales comp is the highest and the marketing is the next. And then the yearly, and the discount is kind of super small. So probably this what, from here, what we can say is sales comp and sales are highly correlated. Therefore, it's very important variable that we can use to forecast. So let's say like if we know the next 3 months or 6 months of the sales compensation values, then we can forecast how the sales is gonna be like even better than just based on the yearly seasonality and the trend. So if I go to the effects, and then you see this like a red line is that how much of the effect from the sales comp, and compared to how much of the effect from the marketing or other variables. And also, like you can see the summary, now like RMSE is 13, and then this is much lower than the without external predictors. And then so the detailed information, I put that in the slides. And then so if you're interested in, like I'm gonna publish this slide after this seminar, and I recommend take a look at. And also most importantly, you should give a shot, give a try, and by using, I'm gonna host that data as well, so you can try it out with Exploratory. Okay, so with that, I think it's already noon, so I'm gonna kind of finish off here. And if you have any question, I can take for the next couple minutes. If you have any question, please send that into the chat window,